Hello everyone and welcome to Network Playroom. This is going to be the final part of the Advanced STP Features video series. This video will focus on BPDU Filter. If you haven't seen the other parts already, I've covered PortFast and BPDU Guard in the previous videos. I'll leave links in the description so you can go watch those if you like. Now before we discuss BPDU Filter in more detail, let's quickly recap how BPDU Guard works so you can understand the difference. In short, BPDU Guard prevents a port from receiving BPDUs. If the port still receives a BPDU, it is put in the error disabled state. The port will still continue to send BPDUs. Now keep these behaviors in mind as we compare them to BPDU Filter. Now, on the contrary to BPDU Guard, BPDU Filter prevents specified ports from sending or receiving BPDUs. That is the gist of it, but the feature operates differently depending on how it is configured. Now, as with BPDU Guard, there are two methods to configure BPDU Filter. You can configure it globally using the spanning tree PortFast BPDU Filter default command, or per interface by using the spanning tree BPDU Filter enable command. So let me write that down. So there's the global configuration, which is spanning tree PortFast BPDU Filter default. Then there is the interface level command, spanning tree BPDU Filter enable, like so. Now the interface configuration filters both incoming and outgoing BPDUs unconditionally and independent of the operational PortFast state or access/trunk mode. This is effectively the equivalent of turning off STP. Now a note here, the key word to stress here is effectively, but not actually. Spanning tree is still running on the interface, and if you would disable and then re-enable the port, it would go through the spanning tree states. So BPDU Filter does not actually turn off spanning tree, but it behaves that way. And this can be very dangerous because a permanent loop can easily be created. However, interestingly enough, iOS does not display a warning message when this command is applied. Now, if we compare this to PortFast, enabling PortFast on the wrong interface, which can also cause a temporary loop, is not nearly as risky as BPDU Filter, yet oddly, iOS considers that significant enough to inform the administrator. In other words, you get a warning for enabling PortFast, but no warning for enabling BPDU Filter, which is much more dangerous. Now let's look at the operational details of BPDU Filter in more detail on the diagram. So let me actually create another layer for this that I can easily delete. So again, we have a very simple topology here consisting of two switches, S1 and S2. S1 is the root switch, and the switches are connected via two links using Ethernet 0/0 and Ethernet 0/1 on both ends. Now, if we look at the base state, when spanning tree is running normally and no features have been configured yet, let's go on the left-hand side to the command output. So right here, if we run the show spanning tree command on S1, you can see that both ports are forwarding their designated ports because this is the root switch. And on S2, right here, you can see that Ethernet 0/0 is the root port and Ethernet 0/1 is blocking. Now, what happens if BPDU filter is enabled on S2? So BPDU filter is configured on both interfaces as shown right here. So let me write that down on the diagram here as well. So BPDU filter is configured on both interfaces. Like that. And now we can see what happens here. Scroll down the output a little bit. So this output is from S1. So S1 thinks it's the root, and it is originally the root switch of the topology. But right now here, if we issue the same command on S2, it also thinks that it is the root switch. And this is because BPDU filter is blocking both incoming and outgoing BPDUs. So S2 is not aware of the existence of S1, and it doesn't know that they're directly connected via those two links. And because of this, all links are forwarding. So if you can look at this output on S1, both ports are designated forwarding, and the same on S2. Well, this is not good, because if we scroll down a little bit, actually before we look at the bandwidth utilization, let's just make sure here you can see that S2 is not sending or receiving any BPDUs on both interfaces. So now let's take a look at the bandwidth utilization. And I just noticed a typo in my document as well. Let's not pay attention to that too much. So right here, if we issue the show interface command and narrow the output to the link utilization, so you can see how many packets are being sent and received right here. So that says over 20,000 packets per second. And we have similar output for S2 right here. If I can highlight this. Yeah, there we go. Now, as it states in the document as well, this is a lot of packets in a short period of time. And note, when I created this document and ran this lab, these are the only two devices in that lab environment. There's no other devices, no other traffic, and yet we're still seeing so many packets being sent across those links. So now you can see how dangerous this command can be. Now let's move on to the global configuration option. For that, let me actually just erase this text right here. So the global configuration is more intricate. Now, similar to the BPDU guard feature, the global BPDU filter is enabled on interfaces in operational PortFast state. In global mode, the switch does not filter incoming BPDUs, but most, though not all, outgoing BPDUs are filtered. Now, when a port comes up, 11 BPDUs are sent out, and if BPDUs are received, the PortFast and BPDU filter features are disabled. So let's take a look at all of this in more detail using the diagram and the command output. So let's go right to this section here. It says both interfaces on S1 have been configured with the interface BPDU filter to stop them from sending BPDUs. So BPDU filter is configured on S1, both interfaces. So S1 is not sending or receiving PPDUs. However, both interfaces on S2 have spanning tree PortFast trunk configured so that PortFast will be operational no matter what, and BPDU filter is enabled globally. So on S2 we have PortFast. If I could type that correctly, PortFast trunk, and then we have BPDU filter globally. So let's verify that configuration on the command output here. So you can see on S1, BPDU filter is enabled and no PPDUs are sent or received. And on S2, in this output, you can see that PortFast BPDU filter default is enabled. So PortFast is enabled on both interfaces, but actually we can see from this line above it that PortFast BPDU, excuse me, not that line, I'm referring to this line. That was BPDU guard. I wanted to check the PortFast feature. So that is referring to PortFast global mode. So the PortFast feature is configured on the interface on S2, Ethernet 0/0 and 0/1. So now if we look at the output further, S2 sends 11 PPDUs and then stops on both interfaces, like so. Now let's see what happens on S2 when the interface BPDU filter is disabled on S1 and S1 starts sending PPDUs. So this part right here, we're disabling BPDU filter on S1. So this one is gone. And here is some debug output from S2. You can see here that eventually Ethernet 0/1 goes into the blocking state. Now this is because S2 hears a superior PPDU coming from S1, which effectively disables BPDU filter and converts to normal STP operation. Therefore, Ethernet 0/0 becomes the root port and Ethernet 0/1 is blocking. So once S1 starts sending PPDUs, S2 reverts to normal operation, spanning tree operation, and this link goes into the blocking state and this port becomes the root port. Now finally, let's come back to the 11 PPDUs that are sent out when BPDU filter is enabled globally. So for that, let me get rid of this layer and create a new one so we can draw more. Now, why are any PPDUs sent out and why specifically 11 PPDUs? I believe 11 PPDUs comes from sending one PPDU at the start and 10 more PPDUs for the duration of the max age. And since max age is 20 seconds by default, and PPDUs are sent every hello interval, which is 2 seconds by default, that allows 10 PPDUs in that time period. So it's one PPDU at the start and then 10 PPDUs during the max age, which are sent every 2 seconds. And that's totaling 11 PPDUs. And by the way, I have not verified this information, so don't quote me on it. This is just a strong hunch, which means it's more of a guess based on intuition than fact. So we can write that down. 11 BPDUs. So 1 at start plus 10 during max age. And they are sent every 2 seconds. This is based on the default spanning tree values. One way to test this would be to run a lab where you change these values and check if more or less BPDUs are sent. This is actually a suggestion from my friend, the great maestro, Peter Pollock, so I might come back to this later in another video. Now to the question, why are these outgoing BPDUs needed in the first place? So let's go back to our earlier scenario where BPDU filter was enabled on all interfaces, which formed a loop and caused bandwidth utilization to skyrocket. The links were almost instantly flooded with packets just from spanning tree. There was no other traffic. That's when I showed you there were over 20,000 packets per second. Now imagine that you have PortFast, which allows a port to go into the forwarding state immediately, skipping the listening and learning states, added to that mix. So PortFast and BPDU filter is very, very dangerous combination. So let me actually add another layer here so I can draw without messing up the 11 BPDU section that I wrote down as well. Now imagine we had PortFast configured on all these interfaces and BPDU filter in global mode operated in the same way as it does in interface mode. So what would happen is, as soon as these interfaces are enabled, they would go from the down to up state or forwarding state immediately, skipping the listening and learning state, and effectively instantly creating that loop that again would flood the links with packets immediately. So instead, when BPDU filter is configured globally, it has a security mechanism to prevent this catastrophic situation. And this is done by sending those outgoing BPDUs and not filtering incoming BPDUs. Now, if you remember from my previous videos, PortFast is a conditional state based on incoming BPDUs. If a BPDU is received, the PortFast feature is disabled. Now, since globally configured BPDU filter is dependent on PortFast, it will also be disabled. So when the interfaces go up, both sides start sending BPDUs, and this will then disable PortFast and turn off BPDU filter. And eventually both switches will revert to normal spanning tree operation. So let me repeat that and demonstrate it on the diagram here. So instead of the catastrophic situation which I just described, where PortFast was enabled and we imagined that BPDU filter global mode operated as BPDU filter interface mode. So now how it really works is that the ports will send outgoing BPDUs, and if BPDUs are received, it will basically turn off PortFast, which then disables BPDU filter. So let's look at that from S1's perspective. So now, once these interfaces are enabled, BPDU filter starts sending outgoing BPDUs this way. So let me just write that down here. So this has PortFast and BPDU filter configured. And this is global mode. And the same configuration is applied on S2 as well. PortFast and BPDU filter. If I could type. Okay, so S1 sends BPDUs and actually S2 does the same. So once BPDUs are received, for example, the one S1 sent to S2, PortFast turns off, and since BPDU filter is dependent on PortFast, it'll also be turned off. And everything will revert to normal spanning tree operation. The same will happen on S1. So eventually what will happen, we go back to the original state. Let's delete this. Where switch 1 is the root and switch 2, Ethernet 0/0 is the root port and Ethernet 0/1 is blocking. So we're effectively back to the original state that we had right here. Okay. Now, as a summary, here are the most important takeaways from this video. Number 1, BPDU filter prevents specified ports from sending or receiving BPDUs. Number 2, BPDU filter effectively but not actually turns off spanning tree. Number 3, BPDU filter operates differently depending on how it is configured. And this comes back to my previous point because it applies only to interface level BPDU filter. Number 4, there are 2 ways to configure BPDU guard, globally and per interface. Number 5, BPDU filter interface mode is independent and unconditional. All incoming and outgoing BPDUs are filtered. Number 6, BPDU filter global mode is dependent on operational PortFast state. Most, but not all outgoing BPDUs are filtered. And number 7, in BPDU filter global mode, if incoming BPDUs are received, the port reverts back to normal spanning tree operation. So that concludes our discussion on BPDU filter and ends the Advanced Spanning Tree Features video series. Hopefully you have a better understanding of these features at this point. If you have any questions or suggestions for new videos, you can leave those in the comments. Thank you for watching, and I'll see you next time.